Hi, my name is Patricia Sanford, and I'm director at the Maryland Archaeological Conservation Laboratory at Jefferson-Patterson Park and Museum. Welcome to STEAM Sunday, and today we have a very special treat for you. Dr. Brad Hatch will be joining us to talk about zooarchaeology, or the study of animal bones on archaeological sites.
Hi, I'm Brad Hatch. I'm the Archaeology Division Manager at Dovetail Cultural Resource Group, and I'm going to talk to you a little bit about faunal analysis, which is also called zooarchaeology. I want to give you a little bit of background on myself first, though. I went to school, I got my PhD at the University of Tennessee, and while I was there, I really got into faunal analysis. I studied faunal analysis under Walter Klippel, and we had a huge comparative collection of animal bones there at the University of Tennessee. So I analyzed several collections while I was there, several of which ended up being included in my dissertation. The majority of assemblages that I've looked at have been from Virginia and Maryland, although I've also looked at animal bones from Tennessee, Delaware, and North Carolina. So faunal analysis is the study of animal bones from archaeological contexts. And archaeologists study animal bones just like they do any other artifact they would find, like ceramics or glass or anything like that. And I'm a big advocate of thinking of the study of animal bones and zooarchaeology as just an extension of any other kind of artifact analysis. It can tell you some of the same things, and you use similar methodologies when you're looking at animal bones. Some of the major things it can tell you are the interactions between humans and animals. You can learn information about human behavior, you can learn information about animal behavior, about the environment, what people ate. You can look at changes over time in sizes of animals. You can look at how domestic animals were managed on plantations, and you can look at some of the more mundane things, I would say, in the archaeological record, like how sites are formed. So, whether a site was formed quickly or whether artifacts accumulated over time, and all of that can help us understand the past and understand people in the past and how sites operated. So one of the first things that you look for when you're analyzing a faunal assemblage is you try to determine the species of the different fragments that you found. One way to do that is you can have reference books, and they can have images of the different kinds of elements for the animals and the different species, and that can help you determine species. But there's no great substitute for an excellent comparative collection. And what a comparative collection is it's essentially boxes or shelves of bones from species that are known. So you may have like a whole deer skeleton, a whole pig skeleton, a whole cow skeleton. Oftentimes they're modern bones. So you can take those modern bones where you know exactly what they are and compare them to the fragments you found in the archaeological record to determine what species it was. Generally, comparative collections are built by collecting animals that have been either killed on the road, or maybe if somebody is a hunter, they might have had some deer bones laying around, or the carcass, or even I've seen specifically domestic animals come from things like butchers. You can get the leftovers and you can put that in your comparative collection. And so having a comparative collection allows you to take the little teeny fragments we find as archaeologists and compare it to pieces on a whole skeleton so that you can figure out exactly what species it is and where it comes from on the skeleton. So another type of archaeological data that faunal analysts can glean from assemblages is information on age in animals, and that can help us to understand when an animal died. So maybe it's a young animal, and that could indicate that it was being raised for meat as opposed to something else like milk or wool. And some of the ways to tell, there's several ways to tell age, but I'm going to go over two of the main ones. One is Epiphyseal Fusion, which is the fusion of the ends of bones. And that occurs at different times on different animals, but generally young animals, the ends of their bones really aren't fused. And as they get older, those bones fuse, and it happens in humans as well. So what happens is you start out with the shaft of a bone and the ends, and they're close to each other, and eventually they'll fuse together. This one here you can see is from a younger animal because the bone hasn't fused yet. Whereas this one, the end of the bone has just started to fuse, and so you can see that edge around there where it's just started to fuse, but in some places it's closed up. And then on this one, if you look at this end of the bone, it's completely fused. It's completely together. There's no indication that it was ever two pieces. And that happens at different rates for different elements in an animal. So whether it's a tibia or a femur or a humerus, the fusion of those ends can happen at different times. And it differs for species as well. So if you know your species, then you can start to put those animals into age brackets based on the fusion of the ends of their bones. The other way to tell age from faunal assemblages is to look at the teeth of animals. When you look at the teeth, you can think of it in some ways like our own teeth. We start out when we're babies, we have baby teeth, and we lose those, and then we get grown-up teeth. And the same thing happens in a lot of animals. Deer jaw essentially has teeth through here, but then it has a tooth erupting in the back right here, which means that it hasn't yet reached the age where that tooth completely erupts. So we should be able to age that animal to a certain age based on the eruption or the lack of eruption on that tooth. Whereas if you look at this deer, which is an older one, you can see that that back molar has completely erupted and it's in there. So this is an older deer. The same goes for other species of animals, other species of mammals. This is a pig, and you can see it's got the deciduous molar in the back, the molar in the back that's erupting. So one of the biological aspects that zooarchaeologists look at when they're examining an assemblage is the sex of the animals. There are a couple different markers for sex in animals, and they're not always the same for all animals. For example, deer, the males tend to have antlers. Usually if you find antler, you can be pretty certain that it comes from a male deer, a buck. Chickens and turkeys and some other birds, the males will have spurs on their legs, whereas the hens or the females tend not to have spurs. So that can be a good indicator of sex in an assemblage if you have a bone that would, have that on it. And then another indicator of sex tends to be the pelvis on mammals. They're shaped differently for females as opposed to males. So this is a pig pelvis right here. But just about any mammal you can tell the sex based on the pelvis.